Together we can restore degraded land. This video covers the core part of ROAM, data collection and analysis. Let's begin with data collection. Data for the analysis can come from a variety of sources. For instance, existing data sets like those held by research institutions or technical government agencies. It may also be collected directly from stakeholders and experts through workshops, interviews, or surveys. In some situations where no good data exists, it may be necessary to commission new research to fill knowledge gaps or update old information. Remember, this phase of ROAM should be as open, inclusive, and robust as possible. The end products of your analyses will be used in future to make land use recommendations. Bring stakeholders together to guide decision-making and validate data and conclusions to ensure that your products represent the best local knowledge and science, and that you've respected the principles of free, prior, and informed consent. Now on to the analyses. A complete restoration assessment includes 6 separate but related analyses. Whether you decide to conduct all 6 or just a few will depend on the priorities in your area and the resources available to your team. These analyses can be done simultaneously or one after another sequentially. What you learn from each analysis will inform the others. Analysis 1: Stakeholder prioritization of restoration interventions. The first analysis in a typical restoration assessment aims to prioritize restoration interventions and activities. In Phase 1 of ROAM, you identified a long list of possible restoration activities, including those that can improve degraded forest, agricultural, and protective lands. Now is the time for stakeholders in your assessment regions to pick the best activities based on local goals and needs. Ideally, you will leave this stage with 5 to 15 restoration activities that can be considered priorities. Be prepared to defend this list and have good answers to the question, what makes these activities the best for the region? Analysis 2: Restoration opportunities mapping. The second common analysis is spatial mapping of restoration opportunities, an integral part of any ROAM assessment. This stage involves analyzing spatial biophysical data with restoration information to produce maps of where priority restoration activities can take place. There are 2 approaches to mapping: digital mapping and knowledge mapping. Digital mapping uses computer technology to combine layers of geospatial information to test how suitable land is for restoration. As a simplified example, with spatial data on current land use and land slope, you can use GIS or computer algorithms to label all flat and degraded agricultural lands in your region as suitable for agroforestry, where tree crops are mixed with field crops to improve the health of local soils and waterways. Knowledge mapping, on the other hand, involves applying local knowledge to existing base maps to manually find areas suited for restoration. This option is very helpful in places where digital data is limited. In a typical knowledge mapping exercise, local stakeholders and experts take turns adding their knowledge to existing maps. This way, local knowledge on existing land uses, health of the land, and its availability for restoration can be recorded. Should you use digital mapping or knowledge mapping in your assessment? Both have their strengths and weaknesses. Digital mapping can be precise and efficient, but it can also ignore local realities if they aren't represented in the data. Knowledge mapping, on the other hand, can provide local insights like what trees grow best in the area, but can remain vague when it comes to biophysical information like how much rain falls on a particular hectare of forest in the region. In the end, most assessment teams choose to combine both mapping approaches. How much you use one over the other may depend on how much digital data is available. The end goal of mapping will be to produce maps of the assessment area with land suitable for each priority restoration activity, overlaid with as much biophysical, social, economic, and legal data as possible. A restoration assessment in Mexico produced a final map with 7 layers of information to find and rank priority restoration lands. A map produced in Guatemala, meanwhile, highlighted the best lands for each of the different restoration activities, including mixing trees with field crops to restoring forests and waterway protection. Analysis 3. Restoration Economic Modeling and Valuation. It's important to know where and how restoration should occur, but estimating the costs and benefits of restoration can be just as important. This is particularly true for policymakers who need to know where money must be spent and for whose benefit. The third typical analysis in Rome involves exploring the economic dimensions of your priority restoration interventions to determine which activities will produce the best value for the least cost. The goal here is simple: to estimate the full flow of ecosystem goods and services that each priority restoration activity will produce, minus the costs of that activity. Restoring buffer zones around protected forests can result in more fuelwood for local communities, for example, but it can also expand opportunities for ecotourism in the region. In this phase of Rome, benefits like these are identified, monetized, and compared. Costs can include opportunity costs, transaction costs, and implementation costs. When monetizing natural benefits, remember that the goal is to capture a broad range of values that are important to society, not just those that have value in formal markets. Spiritual and cultural use of land has a value, for example, and should be included in some analyses. Let's see what the cost-benefit calculation looks like for a sample hectare of degraded agricultural land in Rwanda. Under business as usual, crop production earns the landowner $1,000 a year, but it costs the owner $500 to produce the crop, and it costs society $700 a year in soil depletion. If we were to restore with agroforestry techniques, crop values drop, but we gain new value from timber production. The negative cost to society from depleted soil disappear as the agroforestry restoration preserves this important resource. An economic analysis is complete when you have estimated the marginal costs and benefits of each of your priority restoration activities and have validated this information with existing stakeholders. Analysis 4. Restoration Carbon Modeling. The fourth analysis takes a deeper look at climate change benefits. Though an economic analysis will often consider the carbon sequestration benefits of restoration based on potential carbon pricing, it is useful to conduct a more thorough evaluation of the carbon sequestration potential of each restoration activity on your priority list. The Intergovernmental Panel on Climate Change offers several methods for calculating the sequestration potential from land use changes. Once you've calculated the mitigation potential of each restoration activity, you can use that data to inform policy decisions on land use change. This chart shows the carbon sequestration potential of various restoration interventions in Western Africa. Analysis 5. Restoration of presence of key success factors. The fifth analysis helps determine the context for restoration. After evaluating 20 restoration success stories from around the planet, the World Resources Institute and IUCN determined that a number of factors can predict whether restoration activities will be successful in the long run. For example, is there clear motivation for the work among decision makers, landowners, and citizens? Are legal, social, economic, and ecological factors in place to enable the work? Does the implementing institution have the capacity and resources needed for restoration? This analysis of Rome provides a checklist to determine if there will be any obstacles to restoration that you will need to overcome, or whether there are factors that can be strengthened or put in place before work begins. The final of 6 potential analyses for Rome is a consideration of the types of finance and resourcing that may be available to support restoration in your country or region. In particular, you may consider what kinds of funding may be most suitable for each of the restoration interventions identified by stakeholders as priority activities. For each restoration activity type, consider what the source of finance could be, what mechanism money would be delivered through, what restoration benefit or value the money would buy, and whether that money would be channeled through multiple sources. In general, the more specific restoration activity will benefit individuals, the more opportunities there will be for attracting private finance. The more an intervention benefits society, the better the chances are for attracting public finance. When evaluating the potential for private finance, make sure you consider the returns on investment the restoration activity could provide and whether risk mitigation instruments are available in your area. Are there any barriers to investment that might need to be addressed? When all 6 analyses are done, you will have solid information to guide restoration and inform decision-making in your area for years to come. In the next phase of Rome, you will again combine this information with knowledge and insights from key users and stakeholders to validate your findings and develop recommendations for specifically where and how to accomplish restoration.